welcome. So in this example, we're going to graph a quadratic function using properties. So that means we're going to go through the list of all the things and put the details on the graph, and that will help us make a graph. So notice, basically, we don't want to make a table of values because with a function that's more complicated, it's hard to know which values of x are good to pick, right? Although once you find the vertex, you have a good idea of what's good to pick. Let's do it using the properties. Okay, so the first property is, does it turn up or down? So you look at this function and you go, well, a equals 1, which is positive, so that means this is going to turn up. Okay, so you know the parabola looks like that. So that's a nice quick check, right? Then we're going to find the vertex and axis of symmetry, right? So we're going to do h equals negative b over 2a. Right, so a was 1, b is negative 6, and c is 8. Right, so we get negative of negative 6 over 2 times 1. Positive 6 over 2 is 3. Okay, so that's the x value of the vertex and also the axis of symmetry. Right, so that's the axis of symmetry. Right. And we plug this back into the function to find the y value of the vertex. So we have 3 squared minus 6 times 3 plus 8. 9 minus 18 plus 8. Negative 9 plus 8 is negative 1. Okay, so the vertex is at x is 3 and y is negative 1. Alright, let's start putting this on the graph. Okay, so axis of symmetry at x is 3. You're going to have the axis of symmetry. And this is not part of the graph, but it helps us use the symmetry to make a better graph. The vertex is at 3, negative 1. So the vertex is right here. And I know it turns up. Okay, so this is kind of its lowest point, and it's going to turn up. Okay, so let's get more details. All right, we're going to find the intercepts. Okay, so the y-intercept. Okay, we're going to plug in x is 0 in here, so we get 0, 0, 8. Okay, so the y-intercept is 0, 8. Right, so it's going to be up here. Right, now the axis, the symmetry, you can use to get another point. So because the parabola is like mirror image on one side and the other, this point right here, you can see it's like 3 units away from the axis of symmetry. You can copy it, mirror it on the other side. So you can sort of put a point right there because you know the parabola is symmetric. Okay, so you get bonus points that way. Let's find the x intercepts. All right, so we're going to set this equation equal to 0. X squared minus 6x plus 8 equal to 0. This is x minus 4 and x minus 2. So we get x is 4 and x is 2. Okay, so the x-intercepts are at 4, 0 and 2, 0. Okay, so here they are, 4, 0 and 2, 0. You can see that they're symmetric. They're both 1 unit away from the axis of symmetry. If you like, you can pick more points and plug it in. Sometimes it's necessary to pick more points because if you're graphing it, it turns out you don't have any x-intercepts. You're like not getting a very good picture. All right, so let's see, we can fill in more points here. Let's see what happens if I plug in x is 1. All right, so if I do f of 1, I get 1 squared minus 6 times 1 plus 8. 1 minus 6 plus 8, this gives me 9 minus 6, which is 3. Okay, so this gives me 0.13. So you get 1 and 3 here, and because it's symmetric, this is 2 units from the axis of symmetry, you can put another point on the other side. All right, good, so this gives me a really nice set of points to work with. Now you're going to make that parabola shape as best as you can. Alright, there you go. So there's the graph of this parabola right here. So this is graphing using properties, finding all these details, and then adding them to the graph as you go along.